Welcome to TeleGeography Explains the Internet, the show that explores the business behind all of the ways humans stay connected around the world. I'm your host, Greg Bryan, and today we are continuing our 5-part series explaining exactly how data actually moves around the world. If you didn't listen to the first 3 episodes in this series, please go back and check out what is the Internet, what is the transport network, and what are data centers first, as each of those episodes builds on the previous one. So today, we're talking about the cloud. Our last episode was focused on data centers, but we didn't talk very much about what actually happens on the rows and rows of servers you would find in those facilities. You may have heard this popular saying, there is no cloud, only other people's computers. If you listen to this show, you may have heard me say it, as a matter of fact. And I also like to add that it's other people's wires connecting those computers as well. And this saying is, in a certain sense, perfectly true, though, as you can imagine, it can get much more complicated than that. What that saying is getting at is certainly accurate. Many of us have this vision of the cloud that is just there. It's something you don't need to think about in terms of its physical presence and location. In fact, as I often say, every time I see a diagram of some kind of telecom or network setup that includes a cloud, I remark that the cloud part is just what we're assuming to be there or taking for granted in that particular view. It's the part that you're not talking about right now. The way that we could frame the question, what is the cloud, is to ask deeper questions like, where is my data stored? Why is it stored there? Where do my applications actually come from? And of course, the answer to these questions is indeed someone else's computers, connected by someone else's wires. But let's look at why there is a cloud to maybe fully flesh out this question. So if we start at the fundamentals, why does it make sense to store my data, run my applications, or to do anything else as a service in a place remote from where I currently am sitting or my device is? Well, there's many potential answers to that question, but first there are clear economies of scale to housing many computers in the same facilities where they can share security, power, cooling, network operation centers, security operation centers, etc. Even if that is the case, though, you have to be able to get to them from wherever you and your device are located. So really, the network was the real enabler for cloud computing. So let's think through this network as the enabler with a specific example. We'll use a cloud content provider that everyone listening has likely used at some point in their lives, Netflix. So I was a pretty early adopter of Netflix. I joined the service in the early 2000s. And at that time, Netflix meant a service where you selected a DVD from an online library and had it mailed to your house to be returned a couple of weeks later after you watched the DVD. At that time, the 2 to 3 days it might take for a DVD that you have selected to show up at your house in the snail mail was actually similar to the 2 to 3 days it would have taken to download a digital copy of that film from a probably illegal peer-to-peer site. And Netflix had the benefit of being a totally legal service. Broadband was pretty slow at that point, and networks hadn't developed to the point where you could get something as large as a movie to your house in less than a few days. So as core and especially local or last mile networks became faster and more robust in the late 2000s, Netflix and other began to be able to deliver video content as a streaming service from central computer servers. Now, this is a consumer version of cloud, but of course, a huge part of the market is getting corporations to move their data and applications to other people's computers. And, they might have different considerations than you and I as consumers. So as you know, Jeff Bezos is one of the richest people in the world at any given moment, in the top 3 from what I recall. What you may not know is that arguably much, if not most, of that wealth comes from the cloud, not retail services. Amazon was growing rapidly in the early 2000s, and to deal with some of the challenges of running a massively demanded website, they started the division Amazon Web Services, which has become Amazon's consistently most profitable business segment. So it might be useful at this point to get into some history that we lightly touched on in the data center episode. Before cloud providers like AWS, Amazon Web Services, came along, most enterprises had data centers, which they housed their web servers, corporate databases, applications, DevOps, and whatnot on computers on their own campuses or their own buildings. So, depending on the scale, a closet in the office or maybe a huge basement on a large corporate campus was where most of the compute, data storage, and DevOps happened at any given corporation. Also, at this time, most software was run directly on a device. What I mean by that is that you had to download the software from some storage device onto the computer that you were using. So for those of you listening to this who are under, I guess, 35 or so, we used to order software and maybe have it delivered in the mail, or actually go out to a physical brick and mortar store and buy a disc or maybe a CD, like an optical a disc that you'd put in an optical drive. And then you would download the application onto your computer and use a long string of letters and numbers, a key that came in the box with the software in order to activate the software on that device. And then, of course, you could never activate it on another device, or you had a limited number of those keys from the same disk. So while centralized computing wasn't a new idea at this time, by the late 2000s and early 2010s, the network was robust enough and central or offsite data centers were emerging to host software centrally and then use it over the internet as a service. Now, it's hard to imagine storing applications or even data locally on your device in most circumstances today, but it was very much the way that everything worked until we got to this new model. Of course, as data, software, content, and all things digital left the corporate premises, they don't just go to an imaginary place, the cloud. As we discussed in the data center episode, where those data sit matters to the users and systems relying on them because of something called latency, which latency is just the amount of time that it takes for data to get between your device and you and wherever it is stored. So some applications are very sensitive to latency, video, especially video calls, things like that, where real-time compiling of all those ones and zeros really matters. Other applications, like, say, reading an email, are very insensitive to latency. But even still, any application needs to be able to communicate with its server, and being able to be physically closer to that server is going to lower your latency and make your applications perform better. So over the years, cloud providers have expanded their footprints to locate these services around the globe and enhance performance for those who weren't maybe sitting near a large internet market, like where I am in Northern Virginia. That is a little bit about what the cloud is and how it developed. But to take a deeper dive into the current cloud market, I'm going to enlist the help of my colleague, Patrick Christian, who is our principal investigator for cloud services, and make sure we nail down some key definitions and concepts that I am not personally an expert on. Welcome back to the show, Patrick.
Thanks. Great to be here. Thanks for having me again.
Yes, my pleasure, as always. So Patrick, as you know, I'm going through trying to explain all the different areas of telecom, and we're on the cloud today, which you are our resident expert, principal investigator on all things cloud. And there's a few things that I wanted to clarify with you to make sure that I was telling the right story. So that's why you're here.
Okay, great. Let's do it.
All right, so I'm going to start out with something that's a major buzzword for the last 10 years, and it's not one of those buzzwords that kind of the hype dies down because it's expanded to everything else, right? So everything in the IT world is now as a service. But I want to break down what kind of as a service actually means and get some examples for each of the key cloud ones, right? So,
Sure.
but let's just first start with, as a general concept, what does as a service mean? Because in a certain sense, like, what isn't as a service, right?
Right.
And what
Right.
did why did we need to start calling things as a service?
Basically, to virtualize or put everything in the cloud. So, just starting very basically, instead of having your laptop in front of you or your computer and you're sticking in a disk with all the data on the disk, or software on a disk to load it up, you don't have that anymore. All of this is done somewhere else on servers that are not in front of you.
Hmm.
So I guess this is the as a service part of it. Is it's no longer in front of you. You're kind of renting or going using somebody else's server instead of your own.
Right. So there was a,
In
there
uh
was a time when we owned things, whether that
Right.
was whatever software, networks, whatever, and now we're sort of more using them on an as needed basis.
Yes, exactly. And this is the idea of like everything is a service. But I mean, I think we should focus more on the three big ones. You know,
Right.
the software as a service, infrastructure as a service, and platform as a service. But I mean, you hear a
Hmm.
new as a service daily. I honestly I had
Yes.
not heard this one before. Just yesterday, I was looking up Netflix, and we were talking about Netflix, and it was referred to as not software as a service, but movies as a service. So
Oh,
MAS,
Maz. All right. Yeah.
So, and that's literally anything you do on the cloud
Let's see.
that is virtual, that is not in front of you, that is using servers elsewhere as a service. So, sure, why not
All right.
MAS?
So maybe if we break it down, as a service means kind of two things at the same time. One, it's that it's remote from you. It's hosted somewhere
Uh-huh.
else,
Hmm.
and you consume it on a sort of lease usage basis rather than own the physical. So movies as a service is actually a great example because you would have owned a DVD. It would come in the mail, and you put it on your shelf, whereas now
Right,
you watch a movie as a service hosted on someone else's server, and you watch it just on an as needed basis.
right,
All
exactly.
right.
So the physical is gone, and now you can just do
Yeah.
it virtually. That's great.
Cool.
Hmm.
All right. So then let's go through them. You mentioned the
Sure.
big three. So I
Yeah,
think
the
most
big
people
three.
know SaaS, but what does it exactly mean?
Yeah, SaaS is, I mean, close to what we were just talking about. But I think for me, when I first started seeing the word SaaS and thinking about what that means, it's funny. Everybody says Salesforce. That's true, Salesforce. But it's also, for example, Microsoft Office or Google Workspace,
Mhm.
where before we would have the little disks and put them in. We get your updated Microsoft Office, and then you load it up, and then all of a sudden you don't have to do that anymore. It's hosted someplace else, and you can just and updates are automatic and all these great things. So
Right.
I think that's where we see software as a service. So you are consuming software that are run on other people's or other servers hosted someplace else. And then the I- infrastructure as a service. This, I think, is the more classic. This is what telegeography really follows. Here we're
As
looking
the
more at the,
cloud. Yeah.
yeah, this is
Yeah.
for us more the cloud, where we're really talking about the infrastructure. Um, and these are services, it's infrastructure, but it's services actually that replace kind of your computer, or
Hmm.
your own server. Services like compute, storage,
Hmm.
and networking. Those are kind of the big three under infrastructure as a service. So the
Gotcha.
compute part, the compute, your processing power, you do that in the cloud, in a data
Hmm.
center elsewhere. Same thing with storage. You're storing your files, your data, your content, etc., on servers in the cloud. So a cloud service provider's data center.
So if I could
And
interrupt you for a second, would that include like email? It seems that was always the most classic. Like, I mean, there was a time when a corporation would have a server in one of their buildings, and that's where email were sitting, right?
yeah,
And would email fit? It feels like software. It feels like an application, but there's a lot of like data. Does that fall under infrastructure?
sure. It will. Well, it's not a service that you would run on infrastructure as a service, but it the services that you offer for compute and storage include
I see. I
email.
see. So it's more like the fact of holding any kind of data is the infrastructure part.
Right. And if you look at like just web hosting, that's
Hmm.
infrastructure as a service too.
Right.
I
Right.
mean, so all of these, basically, when you have compute, storage, and networking, yeah, in this is more the infrastructure as a service, kind of more the bigger picture, more than just the software itself, if that makes
Hmm.
sense.
Hmm. It does.
But
But what
uh,
doesn't make sense is what the difference between that and platform is to me. So I'm glad you're here to answer it. So,
yeah, and
uh,
that's a tricky one, because it's something I don't think everybody's familiar with, except for example, developers like application developers. They'll
right.
understand platform of a service as a service the best because really what you're doing there is it's like you're renting the hardware to
Hmm.
develop your apps in-house,
Right.
so no longer
Right.
you rely on your own hardware within your own IT department, etc. You're kind of leasing this or using somebody else's hardware to develop these apps. So really you come along with your data and your applications, and everything else you are kind of consuming as a service.
Hmm.
So I've heard the analogy of like renting a car.
Hmm.
You rent a car. You don't own the car. You don't have to worry about investing in the car, maintaining the car, etc. You rent the car and you drive the car.
Right.
Okay. So and then you put the gas in and you drive the car, and that's all you need to worry about. So
Right.
in that way. And these are services like AWS is Elastic Beanstalk, or Google App Engine is
Hmm.
are some of the services that they offer that are PaaS.
Hmm.
But like you said, it's not one that kind of your average person knows what the heck that means.
But if you're in DevOps, it means a lot, right? So,
Yes,
yeah.
yes, you understand it a lot more.
Gotcha. All right. And then last, this isn't neatly in the cloud category, but it's oft talked about. Just give us a quick sort of definition of network as a service. And with the caveat that I have talked a lot about NAS on the
Yeah.
show, we don't need to go deep, but just a quick
Uh-huh.
definition in case someone is listening to this and has heard that term thrown about.
Sure. I guess you could see it as it's kind of like a cloud service model for customers to rent network services.
Hmm.
Okay. So
Hmm.
NAS allows customers to operate their own networks without maintaining or owning the actual network infrastructure.
Right.
And we see this a lot, especially in the cloud side. We see that like a NAS provider will offer a range of transport and cloud interconnection services. So connecting to the cloud,
Hmm.
the for example, from point to point transport to get you there, to get you, for example, to an on ramp, which we'll talk about later, I believe,
Right.
or connecting within the cloud or to the cloud as well, depending on the provider.
Got it. Right. But it very much in some cases it fits into that sort of cloud world because it's between data centers connecting to hyperscalers and all that. And so on that note, hyperscalers. So hyperscalers is, to me anyway, a more recent term for cloud service providers, right?
Uh-huh.
Although it's pretty evocative, so it makes enough sense. So who are the big hyperscalers? A lot of these will be, sort of household names if you're in the telecom business at any rate, but certainly not necessarily if you're not, right?
Uh-huh.
And what do they actually provide for corporations, whether it's, a Soho small business to, Fortune 500 kind of multinational?
Yes. Okay. So hyperscalers,
Is
we'll
that is that a big enough question for you? I
yeah,
can
yeah.
hear in your pause.
Well, I'll
Yeah.
simplify it.
Yeah.
No, no. Um, let's see. So the hyperscalers, the content provider, we call them also content providers, OTT, etc. I guess the household names that we all know very closely are, of course, AWS, Amazon Web Services, AWS, Microsoft, and Google. We know these companies for other things besides the cloud, but within the telecom industry, of course, we know them as the major cloud providers. And these are all the three of the US based ones. Now, there are
And I
two
should
other
say,
ones.
just to interject in case people run across it, Microsoft is often referred to as Azure in this context. And I've heard what Google has an acronym that people often use for it. Maybe you can remember what it
Yeah,
is, but like
it's Google Cloud
GCP
or
or yeah,
yeah, GCP, Google Cloud Platform, and
right.
yeah,
That's what I'm thinking of. Yeah. Hmm.
And then there's in Microsoft, yeah, the brand for cloud services is Azure, and then the two other American, kind of smaller in scale than the three bigger hyperscalers are IBM and Oracle. And
Hmm.
Oracle's been moving up a lot recently, building a lot, but they come from a background of working. Specifically with enterprises, kind of on a smaller scale, but
Hmm.
providing, in a sense, kind of a dedicated cloud by accessing their services, their software, their applications, etc., by enterprise. So, from the enterprise point of view, they're probably more familiar with the Oracles and IBMs originally than the AWS,
Hmm.
Microsoft, and Google for
Right.
a lot of these cloud services. And then growing concurrently and just as large in China and in Asia, in globally, but that's where they had their
Hmm.
start, of course, are the Chinese-based providers Alibaba, Huawei, and Tencent. Those are kind of the big, how many are there? Eight, seven or eight.
Hmm. Hmm.
But we can add to this group a growing number of companies like Akamai. Now they acquired a cloud company, and now they're offering cloud services very similar to the other hyperscalers. But also, there's a ton of smaller, more um, focused on kind of niche areas like GP. Right now, the big GPU clouds are huge, like CoreWeave and Lambda and these
Hmm.
types of companies. But
Hmm.
really, these, even though they exist in there, a lot of hubbub, these are very much a smaller scale than the hyperscalers like
Right.
AWS, Microsoft, Google, and Alibaba, Huawei, and
So
Tencent.
so they have like a particular niche in the market, but it's just nowhere near the scale that the
Right.
big eight or so have, right?
Exactly. And there are a lot of smaller regional cloud providers as well.
Hmm.
Um, and and basically, so what they were doing, that I think that was your second question,
Yeah.
just put very easy, simply is for the larger companies anyway, they're replacing the data centers and actually, the on-premise data centers for a lot of these
Hmm.
companies, and all those data center services that they had. And also now in the last few years anyway, they're replacing carrier provided WAN networks as well,
Hmm.
kind of
Hmm.
virtualizing all of this and taking that off their hands of maintaining their own data centers or working with these carriers to do this. Now they can all do it through a cloud service provider and using their hardware and not their own, etc., like we've been talking about.
And so, out of those categories that we talked about, most of these cloud providers are offering all three of those: SaaS, IaaS, and PaaS, right? Um,
Yes.
but the universe of SaaS providers would be much bigger than what we would call cloud providers, right?
Correct. There you have it's the I guess the thing that stands out with the hyperscalers is that they offer the networking part. Yeah, I guess
Hmm.
some of the storage, but storage can be in hosting, etc. But I would say, I guess it's more the networking part that really makes it stand out from kind of the SaaS providers
Right.
and the web hosting companies, etc.
Right, who are just providing a particular application or suite of applications and not
Right,
the infrastructure, as it were, right?
right.
All right, so on that infrastructure, maybe you could break down some cloud terms. These are ones where every time I talk about them, I have to go and check and make sure I'm saying them right. But
Yeah, yeah,
so in the way that we talk about cloud at TeleGeography, and in the way that the industry often talks about it itself, you have these things: regions, zones, and on ramps, and especially in the idea of the geography of the cloud.
right.
What do each of those three things mean?
Yes. And very often you're probably right, even if you don't get it spot on when you're talking about it, because a lot of these concepts have evolved and they're much more general meaning now than they
Right,
maybe originally were. So
right.
it's these a lot of these things have been stretched. So, but in general, and this is super confusing, but it's known. We talk about cloud regions, and this is how many of these companies talk about it. Is a cloud region is a usually physically it's a grouping of several data centers,
Hmm.
usually three, that are all kind of had isolated, uh, logically and physically separated. So for redundancy, so
Hmm.
failover. So if one goes down, you have two others, etc.
Right.
So a region would be a grouping of cloud data centers. Okay, and that also gets confusing because people are you talk about the geopolitical region, or is it the cloud region?
That is not the way we usually use the word region. I would call that a
Right,
cluster. If we could go back in time and name this right now.
right, right.
Yeah.
And then there's the zone. A
Right.
zone is basically a data center within the cloud region.
I see.
So
Okay.
zones would be the individual in it doesn't have to be a physically separate as in different locations. Ideally it is,
Hmm.
but it could be maybe on two different buildings in the same campus.
Right.
But of course the cloud providers hold this all very closely to their chest, so we don't know exactly how these things are set up. We can
Right.
guess some of it, but not everything, of
And
course.
that's for
Um,
security purposes mainly.
correct,
Hmm.
correct. Yeah. And then, actually, to add to the zones, there's something newer. It's called a local zone,
Hmm.
and this is like a zone. It would be a data center, or at least a part of a data center, or a big grouping of servers in a maybe a carrier neutral data center that's closer to the end user. That hence the local
Mm-hmm.
that provides certain services that are latency sensitive. But AWS has the official local zone, but Google offers something very similar to it, low latency data centers, which is often, which is very close. It's the same function. Okay.
And that's getting us really close to Edge, and I had predetermined that Edge was too deep a dive for this high level episode, so we'll leave that
Yeah,
for us. Yeah.
but it'll come
Uh,
up in what we talk
yeah.
about. So,
Absolutely. Yeah.
uh, okay, and then finally there's the on ramp, and the on ramp, and this is another concept that has been stretched. You know, originally, and this is how we see it. It's the location where um, you connect your network to physically connect it to a cloud provider. So this
Hmm.
would be in a carrier neutral data center, and
Right.
you connect through a service like for AWS, a Direct Connect, or for Microsoft Azure, it would be Express Route, and Google, or for Google Cloud Interconnect. They each have a different name, but basically it's the physical connection, doing the cross connect maybe between your edge routers, and you're connecting into their network. That's
Hmm.
where the on ramp is. But for us, if you talk to, for example, a carrier and they say, hey, we have an on ramp to AWS, and we're like, oh, great. You just get to this pop in this data center. But hey, AWS doesn't have any presence there. What are you talking about? Oh, well, if you're in this, you connect to our network, and then we bring you to the data center where the actual interconnect happens.
Right.
So they'll call that an on ramp, but to us that wouldn't be an on ramp. But I guess you could distinguish that as a remote on ramp versus a
The-
primary on ramp is
right.
the one where you actually the action occurs.
It's an on ramp to get you to the on ramp, basically.
Right.
Which, you know,
Yeah.
that's a fair enough concept. Sometimes
Yeah.
you have to, you know,
Hmm.
get an on ramp to a highway that takes you to the highway you need to be on, right? So,
Right. Exactly. An on ramp
yeah,
to the on ramp. Uh-huh.
yeah. Okay, all right. So that is helpful. On ramp kind of makes the most sense of those to me so far. So, but I want to talk about how those have developed over time geographically. So specifically, what I'm thinking of here is we have a fantastic map that you created with, I assume Larry, our map team and whatnot, that shows the
Yes.
development since like 2006. I want to say
Uh-huh.
of where on ramps zones and regions were actually located. Take us just briefly through that kind of story.
Okay, but to take you through that story, I kind of have to. I'll go through the story of the different hyperscalers and when they first started to
Yeah,
build out,
absolutely.
etc.
Yeah.
Okay. So first, like you said, it all started in 2006 when AWS launched their first cloud region. And Microsoft wasn't far behind. They launched their first Azure region a couple years later in 2008, and a lot of the original data centers and on ramps were located in kind of good, dense markets in the US and Western Europe and in Asia as well, where kind of the low hanging fruit, where prices were already low on infrastructure pricing like connectivity, etc. They could build these huge data centers, maybe lower pricing, or close to big urban areas. But you
Hmm.
see these areas roll out kind of in the Northeast, kind of near Virginia, the DC area, and in the West, maybe a little bit north or more in the California-ish regions, and
Hmm.
then in Europe, kind of UK-ish region. This is where you see it all start, but
Right.
it grew very quickly. But um, and now I'll pop over to Asia. And although there were already a couple of AWS and Microsoft regions in Asia, things really started to take off Asia when Alibaba launched their first region in 2011 and
Hmm.
Tencent in 2012.
Hmm.
And of course, they built a lot in China, huge amount of cloud regions in China, but they very quickly spread throughout Asia, at a faster rate than I'd say AWS and Microsoft. Since then, the cloud kind of the race for cloud expansion with the CSPs um, has been, like exploding in terms of number of data centers that have been rolling out. By 2014, AWS and Microsoft had already launched, I think, 10 and then 20 or something like that, very close to that. In 2014 alone, I think Microsoft launched 10 new regions.
Right.
And then who joins the fray in 2015? Google. Google launched their regions, four in fact, and then Huawei joined at about the same time. And for these first like 7, 8, 9 years, they average about four new cloud regions for the big providers, two or three a year. And then after that, they were averaging 15 to 20 new cloud regions a year up until pre-COVID.
Hmm.
Okay. And when we talk about where, like I said, low hanging fruit, it was funny. You would hear the term all the time. The cloud is ubiquitous, da 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 da. But
But it's
yeah,
in
it's
5 locations.
right,
Right?
right.
Yeah.
It's ubiquitous
Yeah.
if you live in North America, Western Europe,
Right.
or East Asia,
Hmm.
because that's basically where everything happened. And then Sao Paulo in South America, and that was the only presence in Latin America for many, many years. But there
Hmm.
was almost nothing in Middle East and Africa and parts of South Asia, almost zero. But over time, now we're seeing these are the big build areas where we're seeing a lot more data centers being built.
And the primary reason that we need to expand cloud presence like that is latency. Are there
Yeah,
other reasons?
yeah. I mean, primarily it's latency. The game is always to get the content closer to the end user because
Hmm.
when um, uh, when these services work better or perform better, they're consumed more.
Yeah.
So
Yeah.
you always want to have, then you have a happy customer, they consume more, works better, etc. So, the name of the game is always trying to get content or your network closer to the end user.
Right. That makes sense. All right, so a little bit more on geography. The last episode in this series was all about data centers. So now we're talking about kind of what happens in data centers. John Yumbo and I certainly talked about how data centers themselves are distributed geographically. We didn't really get too much into the difference between a neutral data center in which a cloud service provider is located and a data center that is a proprietary uh, um, property of the cloud service provider. So why are there those two distinctions, and kind of why do hyperscalers even need their own sort of dedicated facilities like that?
Okay. Yes. Especially at the beginning, what we saw is a lot of proprietary builds in these, what I think most people know about are these huge campuses where they build, just outside of urban areas, a little bit in the countryside, maybe where land is a little cheaper, etc. So these are kind of the core regions, the core data centers that they build out. And if you're looking at okay, wait, one more step. So you have that, and then like you said, there's also, they have presence, a lot of the hyperscalers have presence within carrier neutral data centers. They don't own the buildings, etc., AWS, etc. They're kind of leasing space within the data center. Okay, so why these two things? I think if we look from a customer point of view, what we're really looking at is latency considerations. Okay, these
Mm-hmm.
large proprietary campuses, they're usually far away or farther away from the end user. So
Mm-hmm.
if everything is running there, um, these cloud services will be affected by latency. Basically, it
Right.
depends on the service you use. Some are very highly latency sensitive. Other ones aren't at all, so it doesn't matter.
Mm-hmm.
Like storage or something like this, it doesn't matter if you don't have it instantly. But for other services, you really need the low latency. So you have a lot more building closer to the edge, and the edge would probably be a carrier neutral data center where all other networks are connected, and that's
Right.
probably kind of the closest you're going to get to the end user. But of course, you have to be in every city to get
Right.
closest to those end users. So you're building out a lot of edge.
Gotcha. So I now that I hear your answer, my question was probably the wrong way around. It should have been not why do they have their own facilities if they can all be in the neutral facilities, but rather the other way around. Why bother going into the neutral facilities when they already have their own big facilities?
Yeah. Well, yeah. Well, I just talked about the customer point of view, but if you take it from
Mm-hmm.
the network development point of view, um, you're looking at, okay, the pros and cons. I mean, a lot of this is kind of the greenfield versus brownfield. Do you build
Right.
your own huge data center or do you use somebody else's? So,
Mm-hmm.
if you're looking at network development or building out your network, okay, what are the pros and cons? The proprietary data centers, of course, they cost a lot more, they take a lot longer. Maybe there's more risk because you're doing it from building it from scratch. But the pros are you build it exactly to your own, like specifications. It may be higher cost, but it's very flexible. It's built to your needs, so you know how to build it to scale, etc. For security, all of this.
Right.
So, and yeah, I think a big thing to keep in mind is the scale part of it. They can really build to scale.
Right.
Now, so why even go into the kind of brownfield or the existing carrier neutral data centers? Um, I mean, one aspect of it is it's cheaper, but it is less flexible.
Mm-hmm.
But you're also limited to what your provider offers. Okay, but I
Right.
guess the pro is it's a lot lower risk. Because
It's already
think
there.
about
They
think,
someone else owns it. Yeah.
yeah, think about not building in the US. Think about building in, I don't know, Tanzania
Mm-hmm.
or Bolivia or something like this, where you're not familiar with the local or national laws and regulations.
Right.
That's a lot to take into consideration. and this occurred in Africa, and basically a lot of these different areas where doing a proprietary build, there's a lot of risk and a lot of high risk because you're not sure of the outcome of the build. You're not
Right.
sure of the laws. You try to do all your research, etc., but there's example after example where um, um, these projects have been put on hold or have taken twice as long as they should have, et cetera, because of problems like that. Whereas
Right.
if you have a data center that's been there for 10 years, 15 years, you don't have to worry about that. You just
Hmm.
bring in your servers and buy your racks and build out. Of course, the scale is always going to be a problem,
Right.
but kind of that's the pro. And so there, uh, maybe you don't want to do a huge proprietary build in, for example, Tanzania,
Hmm.
but you can get away with a local build out in a much smaller scale build out in an existing data center.
Right. Yeah. All right. That makes sense. All right, you brought up Akamai earlier, which I've always known as a CDN, and it kind of occurred to me when you brought that up, them moving into the cloud space, that in the whole rest of this episode, I in my solo part didn't talk at all really about CDNs and what role they played in kind of cloud development. Could you just tell us real briefly what a CDN is and how that relates to the cloud?
Sure. I mean, start off with uh, almost all of the big cloud providers offer CDN service. So it
Right.
is a cloud service. In addition to the many, 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 many CDN companies, all the cloud providers also offer their own cloud service, or they partner with a large provider like Akamai or Edgio or
Hmm.
somebody like that, that they provide this service. But caching is, let's see, is basically you're talking about latency again. You're storing content temporarily in a server that's closer to the end user, so it works better, or you can access it
Hmm.
more quickly. So, for example, if a user requests content, um, the content will be pulled, if it's not already there, from a source server and then pulled into the cache, a server that's closer to the end user, and it will be stored there. So, take for example, and this is a great example, like in for the results is like in Africa, caching was a huge. You could really see the positive aspects of caching very strongly in Africa. So, for example, you have somebody's on their phone and they want to see a video, that I don't know, they elephants sliding down hills or something like that. This was a big thing of the day. And so, or just the latest song by whoever.
Right.
Okay, you try to watch the video. If the video is being served out of, say, Google data center in Europe, just the distance to arrive at your phone will mean it's a very slow video. Quality
Right.
will be terrible. You won't be able to watch it, or if you will, it'll just be terrible. But if this video is pulled into a cache that's into a data center in a server that's very close to the end user, hey, guess what? There's much lower latency, the video works, and the internet works. So really, caching is what makes the internet work. Okay, you're
So it's
moving.
like demand based movement of content, essentially.
Right. So you have content that may be stored more centrally somewhere, and it's being distributed through CDNs, through content delivery networks,
Oh, good. We hadn't
closer to
defined
the
it
end
yet.
user.
Thanks. Sorry.
Yeah,
Yes,
yeah,
I
yeah,
found that. Yeah, yeah.
yeah. Content delivery networks. Yeah.
There we go.
It's moved closer to the end user. The content is moved from a source server or origin server to the cache, and then all of a sudden it works. And hey, guess what? In Africa, when all these caches started to go in, a lot of these companies didn't have big data centers or even big presence in Africa. So a lot of these services didn't work very well. And then once the Akamai and Google caches started going in, hey, everything started working very well.
And
And
demand
then
suddenly
guess
looks
what?
really strong. Right.
Yes, and then people
Hmm.
start consuming like crazy, and then the networks get better, the traffic grows, etc. Um, so yeah, so
Excellent. Okay. Yeah.
the yeah, better performance. It really CDNs is what make the networks work, or the internet work better.
That is excellent to know. All right. So one more thing, Patrick, you've been very informative. Thank you. One more thing I want to touch on before we wrap it up is just you touched on this earlier, but how do companies actually connect to their cloud provider? So, from a consumer standpoint, it seems kind of straightforward. Like I go to youtube.com and I stream a video I want from the Google server closest to me, or the cache, right? Or I open up the Google sheet I was working on, for my kids' Christmas list, and sign in with my password and multi-factor authentication or whatever. But as an enterprise, you might sort of you need a more holistic connection. There's a lot more data moving through, and it's more complicated in terms of authentication and whatnot. So if I'm whether a medium sized business or huge multinational, how do I get from my internal users, my employees, to their cloud services?
Yeah, I mean, uh, really, this you can get to it the same way you would, as you just explained. You can get on the internet and
Yeah, you log on to your Google Cloud
yeah, you
account,
just
right?
get into your
Yeah.
account and go on the dashboard. Yeah, it's you can, of course. Um, But what happens is, like for a lot of organizations, or especially larger organizations, is you may want a connection that has consistently good performance, or you need security,
Hmm.
etc. Then you would have something, a dedicated interconnection. So with a dedicated interconnection, and these are services like Direct Connect for AWS, ExpressRoute, or Google Cloud Interconnect. These services where you're connecting at you have a much larger connection. You have you can have a 10 gig or even up to 100, but 10 gig is usually a pretty big connection to
Hmm.
this network. So it's a dedicated connection. You don't have to go through the internet, so performance isn't an issue. And if you have huge workloads, it's better to have a lot of capacity connectivity. Also, you try to connect, depending on what your network is and where your locations are, you can connect closer to the regions where you want to, you have most of your workloads, etc.
And that's where
Um,
the location of your CSP's on ramps really start to matter to you as a
Yes,
company.
that's where that matters, definitely. So that's the dedicated interconnection. Now, if you don't need 10 gig right away, you can always go through a partner dedicated interconnection, which is a partner direct connect, partner express route, etc. Where what they do is they have the 10 gig connection, and then you can break that into smaller increments and only get like a
Mhm.
100 meg or a 1 gig connection to the cloud service provider.
Got
And
it.
then there are other ways too. Those are probably the two most common: the internet and a dedicated interconnection. But there are you can peer with the cloud provider yourself directly, or you can peer through a carrier if you don't have your own ASN, your own network. You can also connect over the internet via VPN, but the big drawback for a VPN connection is just a smaller amount of bandwidth.
Hmm.
And also from the cloud, I'm sorry, from the data center operators, you can do connect to an exchange. They used to be called cloud exchanges. Now,
Mm-hmm.
not as many people call them cloud exchanges, but an exchange or a fabric. You can connect to a fabric to connect to kind of cloud services over their switch. Basically, it's basically a, a exchange point where you're connecting, and you can access multiple cloud service providers that way.
Yeah. So John Yembo and I talked about this in the data center episode. Not that different than how data center providers came up with exchange rooms, meet me rooms, where you could connect to multiple other service providers or ISPs or whatever, instead of having to work out a connection. And Now, many enterprises are multi-cloud, using more than one cloud service provider of some kind. So you can just get to a multi-connection kind of facility rather than figuring out all the direct connects.
Right, right. Like an exchange point. It's kind of the
Mhm.
one-to-many model. You just connect
Mhm.
here, and then you have
We'll
all
take
these
care of it.
different networks available. In before they distinguished to cloud providers versus other providers, but now it's kind of like you just
Just
connect to
connect
everybody.
to everybody. Yeah.
Right. Mhm.
Excellent. All right. Well, on that note, I hope we're connecting with everybody about learning so much more about cloud. I did. Thank you, Patrick, very much for the help.
Oh, you're very welcome. It's good fun.
Awesome. Cheers. All right. So I hope Patrick helped bring a lot of clarity to exactly what the cloud is. But to drive that home, as I have in each previous episode, I'd like to close out with using an example of a YouTube creator who has made and uploaded a video to be sent to their dozens to maybe millions of fans around the world. So this time, our creator has filmed, let's say, 1.5 hours, an hour and a half of footage for their 30-minute show. Rather than tie up local bandwidth on their device, they store this video on a paid service like Google Cloud. And then they use a SaaS tool like Final Cut Pro that's hosted in the cloud to do their editing, leaving the original footage on the cloud server and saving their edited version as a new file there. During that process, our creator uses maybe some stock footage or content as a service, really. They got that from a subscription service that they use with copyright-free images or footage to splice into their video. And then our creator does the same for music, using a service where creators can select from stock music with the proper licenses for their show type, all sitting on computers in someone else's facility and being connected to them by the wires of the network that we've been talking about throughout this series. Finally, as in the other episodes, the creator is going to send their video off to be stored on Google's servers and cached based on viewership. So Patrick talked about those content delivery networks. If our creator's video gets particularly popular in a certain market where Google doesn't have servers very close by, they'll use their CDN to cache that video that's closer to where those viewers are so that they have a better experience. And that would be the life cycle of our video using cloud services. All right, until next time, we'll have one more episode in this series all about corporate networks, which we call wide area networks. And then hopefully you will understand the fullness of the telecom world and how we push bits of data all around the globe. Thanks for listening. TeleGeography Explains the Internet comes from the experts here at TeleGeography. It's edited and produced by Jane Miller, and it's hosted by me, Greg Bryan. To learn more about our data, jump over to telegeography.com, and we'll see you on the internet.